Point 7 is going to talk about function notation and some more work with domains. Let's start with some function notation stuff right here. So we've got two functions. This is our x-axis down here. This is our y-axis up here. And then we got our two functions, f of x and g of x. So let me highlight those as well. So here for that one, and then another one for this one. So great. No longer stuck in black and white here. All right. Now they ask you to find a bunch of things here. It really is going to amount to finding a couple things. And let's see what you can do. But this notation, f plus g of negative 1, really means f of negative 1 plus g of negative 1. And then likewise, that's going to be f of negative 1 minus g of negative 1. And so on. Yeah. F of negative 1 times g of negative 1. And finally, f of negative 1 divided by g of negative 1. So your mission, should you choose to accept it, is try and figure out, well, what's f of negative 1? What's g of negative 1? You get these values by looking at the graph here. Now keep in mind that this is your y-axis, which is why I drew it in there. So it's going to help you maybe locate f of negative 1, g of negative 1. Find those y coordinates. That's what's going to give you your f of negative 1 and g of negative 1. So let's see, Arden, maybe you can help me out. What would f of negative 1 equal? Yeah, f of negative 1 is just going to be the y coordinate right here. So it's going to be 1. Someone else want to give me g of negative 1? Johan?
G of negative 1 is 4.
Yeah, g of negative 1 is 4. So f of negative 1 plus g of negative 1 is 5. Now the rest of these are just, really making sure you understand the notation. This is going to be 1 minus 4. This is going to be 1 times 4. And last but not least, you're going to have 1 divided by 4. So nothing really special with the rest of them. It's just, again, understanding the notation there. Let's dive into it a little bit deeper with example B. And if you've got the Desmos link for that, you can open that up. But the first one we're going to look at is this one, and mechanically, example B, f of x is 3 minus x squared, g of x is x squared minus 4. And the first part asks you to find f plus g of x, which really means f of x plus g of x. I mean, for myself, personally, I don't use this notation very often, mostly because I feel like it's more abstract. It just means to add up f of x and g of x, which is 3 minus x squared plus x squared minus 4. What's going to happen when I do that?
X squared cancel out.
Yeah, thank you both.
Becomes negative 1.
Yeah, you're just left with negative 1, which is kind of strange. In fact, you can see that if you look at the Desmos graph. So let's see if we can't do that. Might want to make that a little darker for ourselves. Here's f of x. G of x, of course, is going to be a parabola that faces upwards, but shifted down by 4. So that's this one. But when you add these, bam, you just get a straight line. There's your f of x plus g of x. It's a constant function. So, wow. Okay. Let's keep going with a couple more of these. They ask you for several things here. They ask you for f minus g of x. So that's f of x minus g of x. The place that people are going to go awry here is in subtracting g of x. That's because you've got to be careful and distribute that negative sign. It's minus x squared plus 4. And then we can simplify it. Dalen, how's that going to simplify?
Negative x to the second power.
How many negative x to the second power do I have?
2.
Yeah, so negative 2x squared plus 7. Cool, thank you. Let's keep going with f of x times g of x. So it's going to be f of x times g of x. So 3 minus x squared and x squared minus 4. Lucas, what comes to mind when I look at this one?
God.
What do we have to do to clean it up, multiply it out?
Multiply it out, so 3x.
Is there a word that comes to mind?
What?
Might start with an F.
My foil?
Foil, there you go, yeah. So first terms,
So
actually, you know what? That should be a squared here, my bad. I was thinking ahead to the
I
answer.
was gonna say 3x.
Yeah.
Why?
So 3x squared
3x squared minus 12. Minus x to the 4th.
x to the 4th, yeah, these add,
And then minus 4 plus 4x squared.
plus 4x squared, perfect. Now, we're gonna do this soon enough that it's not a bad idea to get used to this. And that is, we're gonna start working with polynomials, and when you're working with polynomials, it's gonna be convenient for you to put these in descending order. So that's gonna be minus x to the 4th plus 7x squared minus 12. Now the cool thing about knowing, what this polynomial looks like is that just by knowing this, I can tell a few things about this graph. I know that it's going to behave somewhat like this. It's going to be facing down on both ends. It's going to be symmetric with respect to the y-axis. So this isn't perfect, but it should be symmetric with respect to the y-axis. And I can tell all this just by looking at the form of this function. So again, that's things to come. Let's keep on working on what we've got in front of us. The last part of it is f of x divided by g of x, which is simple enough, but then they ask you for the domain. So that's going to be, let's see, 3 minus x squared over x squared minus 4. What are our concerns about the domain? What do we have to worry about for a problem like this?
That one is
Zero
equal to, it can't be 2.
Yeah, the denominator can't be 0. So we want to know, well, where does the denominator equal 0?
At 2.
How'd you solve that?
Plus 4 both sides and square root.
All right. So we get x equal 2, and you got 2 points out of 4. There you go. You need the plus and minus. There's a positive and negative square root. So now that's where the denominator equals 0, but these are the points that I want to avoid. So as far as avoiding them is concerned, I want to cast kind of a big hole around 2 and negative 2. If I was to ask to do this in interval notation, and I wanted to avoid these points, then it'd be negative infinity to negative 2, union negative 2 to 2, union 2 to infinity. Always left-hand endpoint to right-hand endpoint, and that would be your domain. Nice.
So the domain is negative 2 and 2?
The domain doesn't include negative 2 and 2. So these points would not be in the domain. So if you looked at the graph, you could kind of tell that. It's a little bit harder than looking at this, but let's see. Let me just do it here. Y equals 3 minus x squared divided by x squared minus 4. You can kind of see that, yeah, at 2 and negative 2 that there's problems, right? And the graph kind of has this weird spike. It's called a vertical asymptote. Yeah, it's kind of cool. Let's see, we do x equals negative 2 and x equals 2. So put a couple dotted lines up here. I'm putting them dotted because the graph doesn't really include these points. It never touches them. It comes really close. But if you zoomed in enough, you can see that there's daylight between these two lines. It's just a matter of zooming in enough. All right, so cool. Let's keep going. Yeah, question, please, Amber.
So when do we plug in a random point between like negative 2 and 2 and
Oh, that's if you're testing. So if I gave you an inequality and I said, well, when is this polynomial, say, greater than 0 or less than 0, less than or equal to 0, those kind of things. If I gave you this greater than or equal to 0, that's where we would test points in the intervals. Now, the reason you're testing points is because sometimes the graphs are just challenging to look at. I mean, not everyone could look at this graph and go, okay, it's going to go negative, positive for a little bit, and then negative, and then positive for a little bit, and then negative. Yeah, it's tough. Actually, it goes to the left of this point is positive. Yeah, you have to test a total of, oh boy, there'd be a lot of points in here. Because you'd have to have points in the numerator and points in the denominator. You'd have 5 points that you'd have to test. You'd have to test in and around the intervals where the numerator is 0 and the denominator is 0. So yeah, this would be a pain. And one of those points is going to be square root of 3, and another one's going to be negative square root of 3. So yeah.
Would you mind if I close the door?
Yeah, go ahead. Okay, good question. Let's keep going. So we're going to do a deeper dive into domain. And that's going to be looking at the examples in C. So let's take a look at that carefully. Let's see. So example C. We've got f of x is square root of 16 minus x squared, and g of x is the square root of x plus 3. Now what you're going to be asked to find is the domain of f of x plus g of x. So find the domain of f plus g, which is the same as f plus g of x or f of x plus g of x. So an exhausting number of notations for this. That's okay. Well, let's take a look first of all at the domains of these individually. And I'm going to do this one graphically in terms of looking at their domains. So let's shut off all our other graphs and take a look at the graph of, I called it here r of x, in our handout it's f of x, but square root of 16 minus x squared. What's the domain of that function?
Negative 4 to 4.
Negative 4 to 4. That's where the function is defined. So let's write that down, kind of keep track of it ourselves. So the domain here is negative 4 to 4. So let's see, you'll do it this way. There's f of x. Domain of f is negative 4 to 4. Okay, we'll keep track of that. Let's take a look at the domain for g of x. So the domain for g of x. All right, well, let's go back to our graph. Now, we don't necessarily have to go to the graph to look at this. I hope that you can figure out the graph of, or excuse me, the domain of g of x. what's our concern with this function? What are we worried that it's going to happen? Yeah, we don't want a negative under the radical. So basically, we want to know where is x plus 3 greater than or equal to 0, and that's going to be where x is greater than or equal to negative 3, right? So that's our domain. In interval notation, it would look like this. So domain of g of x, well, let's take a look at it graphically, make sure it lines up. Here's our function g of x.
Why do we need to find the domain of g of x?
Well, we need to find where these things overlap, because we're going to add these two functions together. So you've got this one, and we're going to add them together. So for instance, if I wanted to figure out what f plus g of x would look like at 0, I could take g of 0 plus f of 0, 1.732 plus 4.7, or plus 4 should be 5.732. So it should be up here someplace. That's what f plus g should look like. But what if I wanted to find f plus g at negative 4? F of negative 4 is 0, but g of negative 4 is undefined. So really, this picture that I'm going to get when I add these two graphs only exist where these graphs overlap each other. And you can see that when you turn on this last little bit of function here. And the only place that these exist is where they overlap. So let's shut this off. Here's your f plus g. So let's take a look at it in terms of its domain. The domain of g of x was negative 3 to infinity. And I'll do that one in pink. And let's try and figure out what the domain looks like overall. So on one hand, the domain of, let's just write down some points here. Negative 4, negative 3, and 4. The domain of f is everything between these points, including the endpoints, right? The domain of g starts at negative 3 and goes to infinity. But where do they overlap?
Negative 3 to 4.
Negative 3 to 4. That's where they overlap. That's where the graph is defined. That's where the function is defined. So they overlap. In negative 3 to 4. And you can see that when you look at the graph of the function. The graph of the function only exists in that little interval, even though g of x is defined all the way out to infinity. It's okay. They only overlap in this little region here. So that's your domain. Is right in here, including the endpoints. If you look back here, this function is defined at negative 3. It's also the function also defined at positive 4. Now earlier I said that to get this graph, you're really adding up the values from these two graphs. So 1.73 plus 4 should give me 5.73. In this case, to be a little more accurate, 5.732. So all you're doing is you're adding up the points to get that new graph. All right, there was a lot in that one. Are we okay with that one? Sabira, go ahead.
So we found the domain of f of x and g of x,
Yes.
but I thought that was it. Where did
Well, we're trying to find the domain of this new function f plus g. And f plus g is only going to be defined where both of their domains overlap.
so it's not like before where we just had to add both of them.
You can't, yeah, you can't just add both of them. You can't add their domains and get the new domain. You have to look where they are both defined, and that's where the new function is defined.
Is that because this is radical and the other one wasn't?
I'm not sure particularly which example you're looking at, but when I'm adding these functions, it only makes sense to add them where they're both defined. So for instance, when we looked at this graph, the graph of f is defined here at say negative 3.76, but if I tried to find a value to add to it from the graph of g only goes down to negative 3, so there isn't anything to add it to. So it would only be defined where they're both defined, and that starts at negative 3. And it finishes at positive 4. So at positive 4, f is defined, so is g, and so they're both defined there, so positive 4 is also part of your domain. So it's just where they overlap, and that overlap region is here, negative 3 to positive 4. I'm not sure if I've answered your question or not, though.
It seems like the example B and C were similar until that point, where, for example, B, we added them together, but for this one,
Well, all right, let's be fair, though. In example B, we were adding things together, or multiplying or subtracting, but we weren't trying to find their domain. So when you look back at these, this was just a mechanical operation. I didn't ask anything about the domain until we got to the fourth part of example B here, and we had a function here where I asked for the domain. I could do that same analysis where I say, okay, well, what's the domain of this? What's the domain of this? Where does it equal 0? That kind of thing, and get at the domain that way. It's easier for us in this case just to figure out, well, where is this equal to 0 and exclude those points.
I think I
All right, we're going to exclude some more points as well from one of our next examples. In fact, example D. F of x equals the square root of x plus 5 minus the square root of 8 minus x over x. Now there's going to be 3 different areas of concern for us in this problem. There's going to be this one. I'm concerned about this part of the function. I'm concerned about this part of the function. And I'm concerned about this little piece down here. Let's make short work of this part down here. What's my concern for the denominator? Yeah, can't equal 0. All right, so that's one thing that we got to worry about. So x can't equal 0. All right, that's fine. So that tells us we've got negative infinity to 0 and 0 to infinity. But now we got to work on 2 other pieces of this puzzle and then put them all together. I've got x plus 5. I want that to be greater than or equal to 0, which means x is greater than or equal to negative 5. I want to make sure that this is greater than or equal to 0, because if it's less than 0, I'll get an imaginary number when I take a square root.
Whoa.
Yeah, we haven't worked too much with imaginary numbers yet. And then finally, 8 minus x. Same kind of thing that I'm worried about here in terms of this function. I want to make sure that this is greater than or equal to 0. Which means 8 is greater than or equal to x. But a lot of people get this graph wrong because the x is on the wrong side. So, at the risk of embarrassment, let me say this: the alligator eats the bigger number. All right, 8 is the bigger number. That means if I turn it around, if I want to put the x on the left-hand side, 8 is still the bigger number. So, has to look like this. And here with the x on the left-hand side, it's a little bit more user-friendly to think about the graph. So here, our graph is x is greater than or equal to -5. Here, our graph is x is less than or equal to 8. Let's put these on the number line and see where they all overlap. Now, as far as putting this on the number line, let's just put the points that we really need, which would be our -5, 0, and 8. Try and draw the graph for each of these and see where these things overlap. Try and figure out what the domain is. If you're watching this at home sometime in the future, then pause the video and see if you can't figure this out yourself. My famous, infamous manual pause button.
That's not so.
Well, it's just because the software isn't configured to have a pause, which I find frustrating. So I can either record 2 videos, or I can do a manual pause like this.
Have you ever?
Oh, yeah, that's what I told you.
Yeah. Yeah. Oh. Cool.
I like to do it like this one better.
I was just talking about there's 4 areas. They're good all, so ask
Aren't other numbers on this
them out
0 and
yourself.
8?
And if you want
On
to
this
sound
number
really
line?
hip and cool,
0 and 8? The numbers he just covered up. It's 0 and 8, right?
It's yeah, 0 and 8.
Okay.
It's the same now.
Ajax,
but-
Ajax, yes, yeah, different name.
Hmm.
And Snowmass, which is ginormous. So for instance, Pine Knob has like 60 acres.
Yeah.
Snowmass has 3,400 acres.
Snowmass is
Enormous.
in Colorado.
Highlands
Okay.
an aspen.
has one of the biggest verticals out in
Actually, let
Colorado.
me see.
And then there's Watermelon, which I call Water Mild, because it's,
Colorado.
but they got a cool snowboard park. If you're into snowboards, that's where they host the X Games, the Winter X Games. As I have my kids. Pretty wicked. All right.
I
All right.
used to car camp with my cousins up on Snowmass. They live in Aspen.
So cool.
It's they got fireplaces up there.
Nice. Very nice. All right. So this one basically says X is anything other than 0. So I'll just do it that way. What should I draw for X is greater than or equal to -5? Solid dot, arrow to the right. And let me just keep going. And for X is less than or equal to 8,
Going the other way.
solid dot, good, arrow to the left. And now you're looking for where all 3 of these things intersect. So you gotta be a little bit careful here. For instance, do they intersect at 0? No, we got a big goose egg at 0. So no intersection there. What's the left-hand endpoint of their intersection? Where do they? Yeah, so -5, cool. Let's see, Ryan C. Does -5 get a bracket or parenthesis? Bracket. Nice, so -5 to where? Where should that go to? Ryan G?
0.
0 get a bracket or parenthesis?
Parentheses.
Parenthesis.
Parentheses.
Union. Johan, what happens at 0?
I would say 0,
Bracket or parenthesis?
parenthesis,
Nice.
and then
To,
8 with a bracket.
well done, well done. So there's your domain. A complicated problem, but if you take it apart in little pieces, then hopefully you can kind of see that they all overlap right here on this domain. Nice.
So you want to find every,
Is that helping out with these?
yes.
Okay, good.
So you want to find every, the domain of every part and then.
Yeah, where did all these parts overlap in terms of their domain?
Okay.
That's exactly right. Okay, let's keep rolling. I'm going to skip down to example F, and then we're going to come back and look at example G. So example F is more addition of functions. So here's your function F, which goes out to the right like this. And then you got a function G
Oh, it's not.
that, it's on the next page, it's all. Looks like this. But where do they overlap? Where do f of x and g of x overlap?
In the middle.
Yeah, in the middle, right here. From -1 to 1. That's where they overlap. And endpoints here. So that's your domain. And if you take a look at the graph of f plus g only exists right there. That's where f plus g exists. So the domain of f plus g is simply -1 to 1.
How do you
We're just looking at the graph.
determine if it's brackets or not?
It includes the endpoints. Let me make that a little bit clearer. That's why we're including them. Both functions are defined at -1 and at 1. Now the functions themselves, if you wanted to look back at the previous page, they're at the bottom. So f of x is square root of 1 plus x, square root of 1 plus x, and then this is the square root of 1 minus x. So there's your g of x. And you can play around with the domains the same way that we did with the previous one. And it would show you that the domains overlap here. But what I want to focus in on right now is how do you get this graph that I have in blue? I mean, it's the addition of these two graphs. And what you're doing is you're adding these things up point-wise. So point-wise, for instance, I could say, all right, well, if I wanted to find f plus g at -1, then f plus g of -1 is f of -1 plus g of -1. F of -1 is 0. G of -1 is the square root of 2. Because that's, let's see. Oh, I got that backwards. G of -1 is 0. F of -1 is square root of 2. So these are backwards. Now, I'm not really looking for precise values here, but what I'm saying is if you add this plus this value, that's what gives you this height. Or for instance, if I wanted to find this height.
Could you?
Oh, I'm sorry. I'm sorry. If I wanted to find this point, f plus g of 0, f plus g of 0, it'd be f of 0 plus g of 0. F of 0, you can get that from the graph. F of 0 is, that's actually a 1.
Oh, right.
1 plus 1 would be 2. And if you look at our graph, you're getting 2. Basically, what happens is that every point on the graph of f plus g comes from adding up points from f and g. So I'm not going to get into the nitty-gritty detail on these little itty-bitty points in between here, but that's where you're getting these points, is by adding up points from the graphs of f and g individually. Now, that brings us back to example E that we skipped. I've got 4 different graphs here. Let me number them. 1, 2, 3, and 4, just for convenience. And let's highlight some of our functions. So, for instance, this curve graph is our g of x. And then this other graph is our f of x, which is a downward slope line. And we want to add up and get see what we get when we have f plus g of x. And we've got lots of different options here. So it's f plus g of x. This one? Is it this one? Or is it this one? Or this one? Now, if I gave this to you on a test, then here's what you should do. You should start doing a little thought experiment. Say, okay, well, let's take a look here. F of 1 is 1, and g of 1 is 2. So what should f plus g look like? Yeah, f plus g should be 3. But where do you see f plus g at? It's at 2, so that doesn't look right. F plus g of 0 should equal f of 0 plus g of 0. 1 plus 2 equals 3. So that one doesn't look right. And play that same kind of game with some of these other ones. Now, a couple of these might be close enough that you need to do that game a couple times. Maybe pick another point here, like at 6. And find what f of 6 is and g of 6 and see if those match up. And work your way through this until you find the one that looks good. Which one looks plausible for f plus g of x?
Third one?
Let's see. All right, so we got a little debate here. Third one, fourth one. So keep looking, give yourself a few more seconds. All right, so this one fails the test at x equals 0 again, right? F plus g should be 3. Here, f plus g equals 1, so that doesn't look right. How about over here? 1 plus 2 should be 3, and well, this one fails again. All right, so that doesn't look right. How about this one? Does that one look right? Yeah. 1 plus 2 equals 3, so that one looks good. And you can check another point here. For instance, we can double check things at f plus g of 6. So that'd be f plus g of 6. F of 6 plus g of 6 is negative 2 plus 2 gives you 0. And guess what? That lines up pretty good as well. So overall, I'm feeling pretty good about this last one. Number 4 is the winner. Whew. Are you okay with that? I mean, this is right out of your homework. So if you're not understanding this, get some help now, because otherwise you're going to be lost in your homework. All right, so I'll note for my viewing audience that everyone gave me a big thumbs up and a smile. So cool, thank you on that. All right. All right. Let's go down and practice with some function notation to kind of finish things off here. So that's going to be examples F, R, G, and H. This is function composition kind of work here. So hopefully it's some stuff that's familiar from last semester. If not, then hopefully the review is going to help bring it back to your mind. Or whenever last semester was, or your last math class. When you have something like this, You have a function on the inside and a function on the outside. Start from the inside and work out. So let's start out with f of 2, because that's what's on the inside. F of 2. F of 2, well, I better put that into the function for f of x. F of 2 is going to give me what? 5, thank you. 8 minus 3 is 5. And now I can put that f of 2 back in here. So now I need to calculate f of 5. So now let's go back to the rule for f and see what that says. The rule for f says take 4 times x minus 3. 4 times 5 minus 3 is 17. D. Done. Why don't you try working your way through g of 3? You got this? You remember this?
I do. Like I get it now.
I do.
Last semester I failed the question.
Okay.
Now I'm disappointed.
Mhm.
She's got it. That's good. That's good. Start from the inside out. You want g of 3. So g of 3, 5 minus 3 squared. 5 minus 9 is going to be negative 4. That's our g of 3. So, okay, let's calculate g of negative 4, because we're going to take that negative 4 and replace that g of 3. So I want g of negative 4. And I'll do it the same way I did before. G of negative 4 is going to be 5 minus negative 4 squared. So 5 minus 4 squared. What'd you guys get?
Negative 11. Negative 11.
Negative 11. 5 minus 16 is negative 11. Wonderful. All right. Looking good on example G. Mina? Yeah? Hannah?
Yeah.
Okay, cool. Example H. These were my favorite during the pandemic because photomath couldn't solve these things. So it's kind of nice. Yeah, I know.
GPT.
I think ChatGPT would struggle on this one too. Not sure, but you can try it out and let me know. Get back to me. So let's hear. G of negative, f of g of negative 4. So kind of like the last couple, we've got to work from the inside out, except this time they don't give you a function. They just give you some graphs. So we got to use the graph for g. And then the graph for f. So, horrible job of tracing the graph for g. Let's start from the inside out. Now, they give you your x and y axis again. So, let me just kind of highlight each of those. So, here's your x-axis down here. Here's your y-axis here. Of course, these are your reference points to find f of g of negative 4. Kyle, where should I start on this one? Where would you start if you were working on this?
The g of negative 4.
Yeah, let's start at g of negative 4. You start from the inside and you work your way out. So g of negative 4. And Brandon, what's g of negative 4 going to look like for us?
3.
Yeah. So negative 4 is out here. G of negative 4 looks like 3. So perfect. So now I've got f of g of negative 4. But we know that g of negative 4 is 3. So now I want to work on f of 3. Thank you, Brandon. Let's see. What would I picked on you today? Annie. Thanks for volunteering. What's f of 3 going to look like for us? What value am I going to get there? Let's see. 1, 2, 3. Perfect. Looks like a 0. Nice. And that's it. You're done. Yay. Wait a minute. Should we give it some love? Yes? No?
Yes.
All right. Oh, no. Oh, no. Do I need new batteries? Oh, somebody do it for me.
That was easy.
Yeah, thank you. All right. All right. I'm kind of bummed, man.
That was enthusiastic.
Yeah, probably not, but it's all right.
I thought you were gonna do that and then continue. Like, actually, we're not done.
Yeah.
Oh, I'm afraid we're done. I could try and make them harder if you'd like, though.
No.
Are you sure?
No.
I'll just write a special test just for
It was
you.
a question.
Oh, we're not done with
I think so.
the materials here today, though. In case those of you who are getting excited, like I might accidentally let you out early. You should know better than that. I mean, no, not today. Again, another good one during the pandemic because it's tough for GPT to solve these things. But it's kind of the same thing as before. Maybe we'll do 1 or 2 of these. I want to finish up with examples J and K because those are problems that I want you to conquer. They're going to be in the homework. So let's just do this first example, f of g of 3. So f of g of 3. Mina, where should I start with this one?
Find the x column,
Okay.
each row I mean, and
All right.
down the columns g of x.
All right, so g of 3 would be
4.
4. All right, so we'll put in a 4 there. Now we want to find f of 4, so find the column for x equal 4 and move down to f. And what do we get?
No.
Yes. The big 1.
1.
Nice. Nice. Now these last couple examples, and I got a couple here for you, are good ones. And understanding how to tear these functions apart and look at them as being really 2 functions put together is going to help you out in calculus because you're going to have to apply something called the chain rule, which means you understand that there's an outside function and an inside function. And when you take the derivative, it has a special rule to follow. Here, I want to write g of x as the composition of 2 functions. And what are those 2 functions? Well, when I look at this, I see kind of 2 things. I see a reciprocal function, a 1 over something, and I see another thing, which is just the denominator, which is x plus 1. But how do I put these together to get capital G of x? Well, you've got to put them together in terms of function composition. You got to put them in the right order. So what's the right order? You could try g of f of x, and let's see if that works. G of f of x, well, f of x is really just 1 over x. And then I go to my rule for g. G says take whatever I have here and add 1. So this then would equal 1 over x plus 1. Does that look like capital G of x?
Yeah.
Similar. Wait, no, I think.
Looks a little similar, but is it identical? Is it exactly that. No. So that one didn't work. So scratch that one. How about if we try it in the other direction? What if I did f of g of x? Start out with the middle function, or the inside term. G of x is equal to what?
X plus 1.
All right, so this is going to be f of x plus 1. Now we want to apply the rule for f. The rule for f says take the reciprocal of whatever you have. So what is it that I want to take the reciprocal of?
X plus 1.
X plus 1. And that is your capital G of x. So that's the way to go on this one. So the order definitely makes a difference. You can't just put these in any order and make them work. So the trick is to kind of look at this and decide what's the outside function and what's the inside function. So here's our inside function, here's our outside function. The outside function goes first. The inside function goes second. See if you can't figure out an outside and an inside function for capital H of x. Let me write this a little bit bigger. Is 1 minus x to the 4th in absolute value. So again, try and find an f of x and a g of x that you can put together in the right order to get my h of x. So what two functions are you putting together to get this h of x? So there's two kind of functions. And Mina's volunteer. Do you have a question or do you want to tell the answer? I'm not ready for the answer yet. So, but I'll call on you when I think people have gotten the answer. So, oh yeah, the question. All right.
But it might reveal the answer too, so.
Let's give people another few seconds to think on it, another 20 seconds. Come up with your f of x and your g of x. Sometimes there's more than one way to do these things, although generally maybe not. I don't know. I'm not sure if I can generalize that. Kyle?
This is a question about the problem beforehand.
Yes, going back, yeah.
We're trying to find like the f of g of x,
Mm-hmm.
and you have it f of x plus 1, and
Right.
right below it, is that the final answer? Like where do we
Yeah.
leave off?
Because that x plus 1, well, this is just checking it. When you're asked for this on WebAssign, they're going to ask you what's f of x, what's g of x. So you would just type in these. But what I was doing here was just checking that if I did f plus g or f of g of x, it actually gave me the right thing. Your answer on WebAssign, you might be typing in like this. You might also type it in, I can't quite remember, you might type in 1 over x comma x plus 1. You might just list the function separated by comma, but you do have to list them in the right order or understand which order to compose them to get the right function. Mina, I'm ready for your question now. What was?
No matter which one we put as f and g, does g always have to be on the outside?
Well, you can call whichever one you want f and whichever one you want g, but the order does matter. We saw that in the last example, right? G of f of x and f of g of x gave us different things, and only one of them was right. So, call whichever one you want, that function, but I think they want things in the form of f composed with g, which is your f of x, and then your g of x. So let me write it like this, f of g of x. So g of x is going to be your inside function, f of x is going to be your outside function. So yeah, I guess in thinking about that, they do want it in a specific order. So what's the outside function? What's the function you see first when you start looking at this problem? Yeah, the absolute value. So it's the absolute value of x would be your outside function. Dalen, what's that give us for the inside function? What's inside of our absolute value? Yeah, 1 minus x to the fourth. And if you put this together in the form of f of g of x, that would be f of 1 minus x to the fourth. And then you plug that into the rule for f. Rule for f says, well, take the absolute value of whatever you plug in here, 1 minus x to the fourth, and yeah, that's my h of x. So that's it. There's your two functions that you can use with function composition to get the function that they request in example K. Any follow-up on that one? We're looking good there? All right. Let's call it a day here. See ya.